Order of reaction.
Nice.
This video was stupid, so I didn't watch it. I started watching it, I was like, this is dumb, and I'm falling asleep. So, order of reaction is the number of reactants. So that's the order. Under what conditions are enzyme catalyzed reactions first order, and is this reasonable? So, yeah. So, does that mean?
I just remember, this might be a newer question he's added.
Yeah.
Probably described. Well, because let me see if I remember my Chem 106. First order would be as your rate of substrate increases, your amount of product increases, right? They should be directly proportional.
Sure.
But there's a point at which, it's kind of like we went over 376, how, there's a point, this is like your concentration of substrate down here,
Mm-hmm.
and this is your rate or whatever, your product. So as you increase your substrate, there's a point at which you're not really, if you increase your substrate, your rate of your reaction doesn't increase.
Mm-hmm.
Because there's only so many enzymes that can cause the reaction to happen. So once all your enzymes are used up, it doesn't matter if you dump in more substrate, you're not going to get more product. Because the whole idea of a zero order is if you change the amount of reactant, your rate stays the same. Doesn't matter.
Okay, so that's what I was thinking of, and I wasn't sure if that was a good concept.
Yeah.
So, because to an extent, if you just put in a little bit of reactant, and then you keep adding it, it'll go up to an extent. But then eventually the rate will stay constant.
Exactly, and
it'll be zero order because you take the derivative of V0.
We don't. Has he drawn this whole thing yet? Like this is your amount of reactant. This is your amount of product, and we deal. No. This is your amount of enzyme here.
Mm-hmm. And then
this is your
substrate.
Yeah, this is enzyme. Yeah, we deal with things that occur in this state, which is called the steady state kinetics, or if you think this one over here, we don't deal really with the pre-steady state.
Okay.
We deal, because we assume that most reactions, well, it'd be hard because as you vary it, the amount of enzymes varies, but we're just going to say if all enzymes are used, what is their kinetics?
Mm-hmm.
How fast can they turn over product? That's what we're going to study.
That makes sense.
And back to, let me do it right here. Back to 106 model. I don't remember. Did you do sapling when you did 106?
Sapling?
Online homework?
No.
Okay. Because I've been doing it for a lot now. But here, they'll often show 106, they'll show concentration of, let's say, A, and then they say B. And they'll have one where you say there's 1, and then you double A, and then let's say your rate's 4. Let's say your B is just always constant. So if your rate doubles as you double A, and then that means A would be first order. But let's say you keep A the same, but you double B, and then the rate's the same, that's zero order for B. As you increase B, it means B is not acting in the...
Yeah, okay, I remember that.
So that's the whole idea here is that once you get to this point, you increase substrate.
Mm-hmm.
The fact that a substrate has to go into an enzyme, there's only so much enzyme that can be available. So that's why it's zero order.
Okay.
70. Yeah, it depends on the fact that you have amount of ES. And there's really no way to just increase ES because, you can't just add ES in there. You have to, you'd add more enzyme and, that's hard to measure.
Yeah.
Cool.
Cool.